Hello and welcome back to Compiler Programming. Today we're going to continue working on turning our token tree into a working program. And before we move on with functionality, I actually had a bit of a thought in the background yesterday and figured out that I want to change how this stuff works. So since we will have ability to very easily generate code at runtime, it might be easier to actually turn this pattern matching into a function rather than keeping it as like this array and matching it on array. This will also solve some of the problem with capturing like parts of this stuff. So yeah, this is the first change I would like to make. And that will require us to, I guess, create something like big token macro that would accept a token, and it would accept like basically an index, or let me think about this. I guess we will need to have pattern matching state, and then this might even be a function. So let's just think how that might look like. So the idea is that I want to match this stuff. Let me just copy it over here, and I will start writing a function right away. The first thing that we need to decide is how to communicate that back, and as I mentioned in the last video, I think it would be a good idea to create kind of a separate struct for each matching, or like replace it in place. Either way, we will need to somehow communicate that we were successful. So let's start with the simplest form of communication back and just say we'll return a bool saying, did we match a pattern or did we not match a pattern? And let's say token match function definition. We need to pass something over here, and I think we would have like token matcher state, and it will be a pointer, and this state will contain several things. So the first thing that it will contain, def struct, it will contain actual pointer to the token that we are going through, or alternatively we could put an array of children directly, but I think I prefer to have like a root pointer, because it might allow us to better do matching, and like you do more complicated ones, including looking at the root type and so on. So I think that's generally better. And it also should contain like child index, so that we can match not starting at the start of children but somewhere else. So right now we are expecting that our function definition starts exactly here, but imagine that we would have two of them. So we'd have like foo and bar, right? I would have like so. In this case, this function definition will not start at the index 0, so we'll need to be able to match that somehow as well. And just in case you're not familiar, in C you have the like two string literals next to each other. They actually turned into one string literal, so it's just a way to nicer format your code if you want to. Okay, so I'm gonna remove that for now, because for now we will just match at the start. And what else do we need? I guess that is about it for now, what I'm thinking about. And we will need a function that says token star token pick, and this token pick will also get the state, and it will get a delta. So we have this like base index, and then we have a delta. So we'll, for example, say I want to look at the child index, at the next after this index, and the next and next and next, and you will see in a moment how that would look like. So we can say that here, let's say if state child index plus delta more than equals of root, then return 0. Otherwise, return dynamic array get of root children. That actually should be also root children over here. Oops. And we get, let's just say that this is going to be 64 index. Then I take that index, I put it here, and I put it over here. So this is just a safety function that makes sure we don't go outside of the bounds of the children array, and we try to get a token. And now our pattern will actually be expressed, I think, quite nicely. So what we can do is we can say token star ID is token peak of state 0, so kind of the current token. And then we want to say that if not ID, then return false, right? If we did not find a token, then we did not match the pattern. And then we say if not ID type is token type ID, then this is also a failure to match. Okay, so we can even do something like U64 delta is 0, and you can do delta plus plus. So just this stuff will be uniform and will be allow us to easier move around these pieces. So the next thing is what is it? Colon, and if its type is not an operator, then we false. If the source is not, so we say colon source slice. Okay, so that actually should go into here, and we say slice equal like so. Okay, so if the slice is not wrong and not the right one, then we also say it is false. Next we have what do we have next? Next we have just paren. So let's take this one and say that we have paren. If we don't have one, this is not good. If the type is not paren, that it's also not good. And now we are ready for the arrow. So let's say arrow, 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 arrow. Okay, so that is good. And finally we have one more paren and we have body. So let's just say that this is args, right? This should be an argument definition. And here we should have return types. Okay, and the final one is what is curly? So that's curly, and this is body. Okay, that looks good to me. Okay, that is good. Here we say state root and state root. Okay, here we want like so. And finally, if we did match everything, we say return true. Okay, so first let's verify that our function actually works. And for that, we will just say token match function definition, something like here, check token match function definition. First, we need a state, so token matcher state. State is this stuff, so we have root is root, and then we have child index as 0. So we have state, we pass it over here, and then we actually that's all you need to do. Okay, let's try to run a test and see if this works. Okay, it does work, which is great. But one thing you might have noticed when I was typing all of this is awfully repeat heavy. Luckily, we can sort of easily isolate it into helper functions. So you can say token pick type, and essentially it will be like so. It will accept all the parameters, except it will also accept a type. And we say that or actually we can also pull out a trick that we did here, where we were passing in the match like this. This also would work, I guess. Yeah, let's do it that way. Say data and pick match, and here I would just say token star token pattern. Okay, so we can take this code from over here and do this. Actually, it's called pattern token here, and the source token we can very easily create and say token star source token is state, actually is token pick state delta, and we say if not source token return 0. Right, so we are propagating the failure out. So if we didn't find one, we don't need to compare. In terms of functional programming, we are basically creating what's called a monoid. If you want to look into that, you can do, but you don't have to have Haskell to write code like that, which is sometimes a very convenient way to just deal with stuff. Okay, now we don't need assertions as well. We can just say return 0, right? So in case of failure, we just return 0. And in the case of success, we return source token. Okay, so this is a function, but we are not using it yet. Let's do that. And the way it would look like is we would put it here and would say type is token type ID. And if not ID, then return false. Let's check if that works. And okay. So we have now a slightly better way to specify these things, which is very, very nice. Let's transform other stuff as well. And I think now I can actually bring back this stuff because it was actually closer to what we are trying to do here anyway. And we can do some transformation. So this already happens. We do this stuff and we just replace it like so, like so, like so, and here. And now we can actually add our early returns. I mean, we technically don't need early returns because peak will just return us 0. So we could try to like match all of them and do return at the very end, but it is nicer to have early returns. Okay, so this is going to be our args. This is going to be our arrow. And this is return types. And this is body. Okay. So let's just say that this is args. This is arrow. And this is body, and this is return types. Okay. I actually want this one here. Okay, this is slightly better. But if we would write a lot of functions like this, we probably could even simplify this stuff even more with some kind of macros. For now, I'm pretty happy with how it looks like. So that's good. Okay, let's try to rerun our tests to see that we haven't screwed up anything, and we are good. Now, we're still not really using this code, so we are just checking, okay, that we have matched. But we need to figure out now who takes care of processing and what actually happens after the match. Our options are basically so in the case of module, what we could do when we match stuff, we just continue, and we basically say that on the module level we never backtrack. There is no precedence or stuff like this, it's always like a fixed match. This is an option, but long term, I think would be nice if we were not limited by that. And at the top module level, it would behave the same as an expression where we have different types of matches and so on and so forth. So I would not like that. Another option would be that if we did a match, we would replace the match with another token type in the child array, so that subsequent matches would operate on a different thing. That could work as well, I guess. I think for now, that's an interesting conundrum. What do we want to do as a first step? Well, as a first step, let's just return a special struct and see if that works. So we say token match function def struct, and it will return bool match, and it also will return what? Well, it can return as a slice name. It also can return as the arguments. So ideally it should parse out the arguments of the function, right? Right now we are not doing that, but it should. So we would say like array value pointer, I guess, args, or even better, what we should be doing is we should be returning a straight up function value, or at least one of these. Yeah, I think returning one of these would be pretty cool. Then we would be able to easily plug into the rest of our system. I like that. So let's do that. Let's try to do that. We say descriptor function and we say descriptor. Okay. And this is what we will now return. That means that we need to slightly change how our return works. We say token match function result is 0. And where we were returning false, we are now going to return result. And here we will just say also result. Okay. And we say we stick stuff that we found into the result. At least we actually should indicate that result succeeded. So we say result match is true, and then we figure out how to fill in the rest of the stuff. That actually should be a pointer to match the rest of the stuff that we are doing. Okay, here we are. So this should be match. Okay, let's try this out. Okay, that that does work. So let's try to go about generating this descriptor function. How do we do that? Well, we say that result descriptor is temp allocate of descriptor function, or actually this should be a descriptor, not a descriptor function. And we allocate a descriptor, and then we start stuffing stuff into that descriptor. So result descriptor is descriptor, and we say that its type is descriptor type function, and then we have a bunch of fields here that actually deal with what the function is all about. And precisely these fields are this. Okay, so we can probably don't need to touch frozen, at least right now. There is not going to be any overload, so this is going to be empty, and that means we need to deal with arguments, and we need to deal with the returns. And returns is pretty straightforward. I guess I think we have value void, if I'm not mistaken. Let me search for that. Is it maybe in value? Or maybe it is void value. Yeah, it is void value. So we can say void value here for now. And arguments is dynamic array make of array value pointer something like this. Okay, you don't know what void value is. Void value, that's because it's declared in here. Let's move it to be here and just say like. So, okay, now you want descriptors, that's fine. We can give you the descriptors as well. Doesn't really matter. Okay. That is good. We now have this descriptor type function. Okay. So that means we will no longer be using this function helper, I guess, to deal with this function. Instead, we will be using something else. So I will first comment this all out. And this is no longer necessary. We can say that token match function is match function of this stuff. We check in that it does match. We don't need this stuff anymore. And as far as ID goes, we also don't need this stuff. We can just straight up say that match function name is foo. So let's try to run this test and see if that works out. It doesn't, and what fails is this stuff, but this is okay because I actually haven't stuffed it in the right place where we say result name is id source. id source. Okay, let's try it out. That's much better. And now we can continue. Okay. What else do we need to do? I guess next I want to look at exactly what this function helper does. Obviously it creates a function builder, and I know that, but the question is, what else does it do? Function begin. Okay. So should we make use of this stuff or not? Well, it creates this descriptor, and then it creates a builder, and then it does this stuff. Well, I guess we could use this function begin stuff, maybe. So that would mean what does it return? Return the builder, but result is a value. Well, let's try to make it work. So what that would mean? Well, that means that we need to definitely pass in a program, and it also means that we will return a value. Let's think about that. So this would change into a value, and we would say value. This would go away, and now we would say function function whatever function. Okay, and we say result dot value is function undeclared identifier. That is interesting. I mean, this is how you use it, no? Okay. We have a problem with the order that this stuff is happening. But actually, no. The source is included after the function. So why are you unhappy exactly? I guess it doesn't. So let's try to call it directly. Let's say function begin of result value, and what else? Okay, so result value, and we need to pass in the program. Okay, yeah, so maybe that's why it was unhappy. So let's pass in program into here, and we say program, and this would be function builder star builder. And we can try to call function end right away on that builder. So let's just create an empty function. Yeah, so this stuff, I guess with this time that we created a header for the function things. Well, we can do that. Function h. Yep, I do want to change it. And function h will be like this, like this. I don't think we need this stuff. We probably can collapse down these things. We also reduce this stuff that actually has wrong formatting. So let's fix that as well. And I will just keep the functions that I'm pretty sure we will need. Okay, program end. This is also something that we will probably call function arg. Sounds great as well. Function return is also very nice. This stuff is also very good. That is something we will keep as well. Loop end, yes. I don't think we need assertions. This is good. Actually, we don't need this stuff either. We'll just keep plus and minus because this is what is the public API sort of this. Multiply sounds good. Divide, that is also very good. And all of this stuff should also live here. Value pointer to, that is something we will need. Call function overload is not something we will probably need. But this is, we will make and make or, and these are a bunch of things. So here I want to add an and if, and at the very top, if an def function h, define function h. Okay, now I can just do include function h, and I'm gonna get rid of all the macro definitions because they are now living in the header. So all of these goes away, and this stuff goes away. All of these should go away. Okay, let's see how we're doing now. Compare not equal redefinition. That's because it was defined in the header. Loop builder definition. That's also something we can take care of. And finally, the reason we were doing this is because now we want to do function.h. Okay, unresolved external symbol, blah, blah, blah. Okay. This is inside of source spec. It's fine. Actually, this is why maybe it was complaining before as well. Whoa. Function spec. I guess we just take the whole 9 yards and put them over to here. Okay, good. So this is done. We have program underscore, I believe it's called, and we are good. At least we managed to produce something. So let's try to run the tests. The tests are passing, so something is happening. Let's get back to actually doing stuff in our code. So we have a function, right? And now we can probably even use our nice macro. I'm not sure how good it is to actually use it, but it's fine. So say value, and then we'll say result value is value. Okay. Well, let's rename this one to program so it matches the expectations. And this is now very, very nice. Now we can probably take this stuff over here and do stuff with it. So first of all, we don't have any arguments. We don't need to get body because we got it before. This stuff we do need to do. This we'll keep just for the explanation's sake because we will need it in other place once we deal with expressions. Okay, we have body result, and this is very nice. Okay, check here doesn't exist because it's no longer a test. For now, I'll just do assert. Or more precisely, if it's not 0, then assert not implemented. Okay. What else do we need to do? Let's take this stuff out. We are ready to uncomment this stuff. And now this checker is going to be match function value. Okay, let's try to run this stuff. And it works as nice as before. Cool. So even though we didn't add any functionality, I actually like this setup much better because there is now a nice way to match on a pattern. And instead, like, we can even simplify this with macros. So this is very, very good. Now we need to make some actual progress. So actually save this. What do we want to do as a progress? Well, there are a couple of options. Option number 1 would be to try to have 2 functions. Option number 2 will be to expand what we do with a function and maybe accept an argument or something like this. I guess here's what I want to do. I want to verify that the return type is correct. This is what I want to do, because this should be pretty straightforward. And this is how we're gonna do it. We will say if, or maybe even switch, of dynamic array length of return types. Yeah, return types children. And this is what we will do. We will say if it is 0, then we would expect the return type to be void, right? And let me check what the builder actually does by default. So function begin, what do you put as the return? Actually, you put in 0. And this is interesting because I think it participates in checking when we do function return. So what happens when we do function return? Yeah. So if it already has, it verifies that it is the same type. That's actually very good. So let's try to crash it. In particular, we are saying that if it is 0, value returns. Is this how we do it actually? I just need to verify that which I need to modify. Do I modify the builder or do I modify the value? Actually, it doesn't matter. They're both pointing to the same descriptor, so I could totally modify the value. And I say value returns is void value break. Okay. If it is 1, so say to do assert, implement type parsing, and default, we just say, we also assert, but the message is different. Multiple return types are not supported at the moment. This will eventually be a thing, and we will also should be able to like dynamically decide which return types we want to do. So there is all kinds of stuff that will go into this category and even this category a bit, but for now we just want to make the simplest thing to work. And right now I want to see returns is not a member of value. So here I actually should say descriptor returns. It's not a member of descriptor either. Am I missing something? That's because it is descriptor function returns. Goes like this. Good. So we should get an assertion about implement type parsing. And that's exactly what we get, which is good. But the actual assertion I wanted to get is this one. If I don't specify type here, so we return void, then we should actually get an assertion from the function builder that will try to return us 42, but because the type is void, well, it will not work. Eventually, we probably should support implicit conversion specifically for void. Like if you have resulting here as something. It should be still acceptable to put it here, but for now let's just be as strict as possible, because in the beginning you don't want to have syntactic sugar. Like having it just makes your brain melt and thinking about all the cases that can go wrong. So it's better to try to get the first thing work. And this is exactly what I was expecting to happen. So this is assertion that is coming from over here. Right, when we call function return, and we verify that all return paths actually return the same type. So this is great. And now I'm gonna choose it, and our type parsing will be very, very dumb. So basically what we will do is we will say token star return type is return dynamic array get of return types children and 0, and we need to check that it is an ID. For now, at least, it must be an identifier. Assert that return type. You can call it return type token, so it is easier to distinguish it. Type is token type ID. And now we just need to convert that ID to something that we can use. And here is where we would need probably a helper function. I will call it what is the return type? So it returns an operand, but the first thing we need to do is a descriptor, I guess. So descriptor star lookup descriptor type, and we will accept a slice with the name. For now, that's all we will accept. Obviously, that's not going to survive for long. But right now, instead, I'm just going to choose it and say we have these types that are defined globally, and they are just hard-coded. You can't change them. You can't introduce new types. And this is what we're going to live with. But obviously, that's not going to survive for long. And probably maybe in the next video or the one after, we'll introduce scoping and lookups and so on and so forth. But for now, I just want to have something that works. So here I would say if slice equal slice from string literal as 64 and name, then I just return we have this descriptor as 64, I think. Otherwise, I return 0. So let's see how that looks like. Okay, that is fine. That needs to be star here. And that is good. So now I can do lookup descriptor type of return type token source. I'm going to assert that I found it. Okay, and now we are ready to figure out how it will actually go. Let me take a look at function return and see what it will look like. So if it is not frozen and descriptor type is not void, then we would get this thing. So this is slightly awkward because we get this to return, but I think I want to split it into two parts. So it's a function return descriptor, and it accepts basically like so, and this is going to be descriptor, and well, I'm gonna take this stuff, put it over here, and fix anything that happens. So this will be builder, and to return descriptor, right? And function undeclared, and we can just return, actually not void, but we can return descriptor function return, or actually it's fine. I will just take this stuff and say like so. Okay, that is fine. And here we remove the return. That's good. Good stuff. And we have successfully split it into pieces, I think. And the point is now we can call function return descriptor directly ourselves in here. So function return descriptor, builder underscore, which is automatically created by this thing, and we return our descriptor. Does that make sense? Also, what does function freeze do? Ensure frozen. Where does is frozen used? That's interesting. Where are you used? So is frozen is used in so this is all about arguments and return values. Yeah, so we actually should freeze the builder after we do that, but let's try to run this first. And look at that. So this is pretty cool. Now we are also able to where's our test? So now we actually do parse this value, we verify it. I can try this, do this stuff, else if, again, this is not how it's going to look like long term, but I just want to showcase that we do actually parse out that value and use it in our function. So here we go. We have mismatched types. Again, we need to work on the reporting of all of this stuff, but that is okay. We can do that separately. For now, I'm gonna revert this to be a 64, and we have a working function, which is pretty cool. And one last thing I guess I want to do today is, okay, so we have, we are going to deal with arguments at later stage, but we did deal with return types. And at this point, we can also say function freeze of builder, right? So at this point, there should be no changes to the return value whatsoever. And this is pretty great. Cool. Well, I think that will be it for today, but I think we made pretty good progress. So now there is well understandable, I guess, structure of how you want to approach matching. There is definitely lots and lots and lots of things to do for now, but I kind of like that we are also able to reuse a lot of the things from the macros that we are using. So return types are at least somewhat similar. Here we will probably make use of our arg macro or call those functions directly. And once we improve the parsing of the body, it will also just result in all the same things that we were doing previously. So this is pretty nice. Okay, that's it for now, and hopefully see you next time.